Spearman found that memory, spatial intelligence, verbal intelligence, quantitative intelligence, and so on, they all correlate. And then you said that memory aside, they all seem similarly heritable. And this reminds me of something else that I read, was that there are two models. There's the generalist and then the modular model of genes. And I was wondering if this is a good example of the generalist model, but more generally, what the two are and what the distinction is and why it's important.
Yeah. Well, again, coming from a single gene perspective, Mendelian perspective, you tend to think of genes for X and a gene for Y. You tend to think of, you should never say genes for anyway, because, it's not, it's a matter of genetic influence. It's not this gene determines that. But it is that modular thinking that you really see in neuroscience too, where this bit of the brain, here's your brain on drugs, and that bit of the brain lights up. But what research is suggesting, quantitative genetics, is that genes are generalists. That they work mostly across all cognitive abilities, for example. And that's the idea of genetic G. Most of the genes that affect spatial ability also affect your verbal ability and quantitative. And you get people say, oh no, I'm good at verbal, I'm not good at quantitative. But actually they are. They're maybe not as good at quantitative as they are at verbal, but compared to the population, on average, they're going to be both good at both, because the genes are kind of generalist genes. It also means if you found genes for one cognitive ability, the genetic correlations on average are about 0.5. So the chances are you're going to find a gene that's correlated with a lot of other cognitive abilities as well. And where this is really a hot topic now is P. Instead of G, P is general psychopathology. What this genetic research has shown, and especially the genomic research now, is that our psychiatric nosology, the classification of psychiatric disorders, has no relationship to the genetic architecture of psychopathology. So you start with the top of the classification of psychiatric disorders is schizophrenia and bipolar depression, where people cycle between mania and depression. And up until the last version of the Diagnostic Statistical Manual, DSM-5, you couldn't be both, because they were considered, the very first dividing line in psychiatry. Yet when the first, we call them genome-wide association studies, were done using these SNP chips to identify genes responsible for schizophrenia, all the genes they find are also associated with bipolar, which is so mind-boggling, because these are supposed to be completely different disorders etiologically. But the problem with psychiatric nosology is it developed historically. It didn't develop empirically. And so what we've now found is that the genetic correlations between these psychiatric disorders is extremely high. And there's a strong general component. So it really does tear up the diagnostic classification schemes, which come from the medical model, which is a single gene, single cause sort of approach, where you, like in medical epidemiology, you've got a cholera epidemic and you look for the cause, contaminated water that causes this disorder. So your first step is you got to diagnose and say, do they have cholera or not? And so that single factor, single gene approach has dominated psychiatry, who has kind of medical envy in a way. They want to be like a medical illness, but actually medicine is moving towards a more dimensional rather than diagnostic approach. So I think there's just no reality to these psychiatric diagnoses. There are problems. People have problems, but we don't gain anything by reifying them as diseases, etiologically distinct disorders. And so it's really it's revolutionizing psychiatry already. I find at the Institute of Psychiatry, I find psychiatrists you'd think they'd be very upset by this, because everything they've done is according to these diagnostic manuals. And I'm just saying the whole architecture is wrong. But on top of that, it isn't even a disorder. It's just a dimension. These things are quantitative. They're not either or. So anyway, that's a long story itself, but I think this does relate to the idea of generalist genes, which we've known about for a long time with cognitive abilities, but we're just beginning to see that in psychiatry as well, most genetic effects are general. So if you have parents who have psychopathology, your risk of psychopathology is greater, but it doesn't work. It isn't inherited in a true way, like, schizophrenia could relate to ADHD in children. So I'm glad you brought that up. It's often hard for people to get their head around the idea of generalist genes, but I think it is a very important finding in the area.